In this video, we are going to look at different UDP-based packet attacks and DNS-based packet attacks. So first, let's take a look at what is the mechanism or what is the anatomy of a UDP flood attack. What the UDP flood attack does is that the attacker is going to generate a lot of large-sized UDP packets, and those UDP packets are going to generate a lot of traffic on the network, and they are going to require a lot of resources to be consumed by the servers to process those requests. In order to defend our network and our infrastructure against the UDP flood attacks, we can either use a relationship defense mechanism, or we can use the fingerprint learning on the firewall to protect the network against these attacks. If we have a UDP flood attack, we can use the relationship mechanism between the UDP packets and the TCP packets to protect our network against these attacks. So for example, normally the gaming servers or the gaming traffic uses the UDP protocol. However, if you want to authenticate, the initial authentication, user authentication in these types of applications uses TCP. So what the firewall can do is that if it receives UDP packets from a potential attacker, or if it wants to make sure that the traffic is not coming, or the traffic coming in is not the attack traffic, what it does is that if we implement this, the firewall is going to intervene, come between the server and the attacker, and it is going to, when it receives the traffic from the attacker or from any client, it is going to request, or it is going to ask the client to send TCP packets. So when the TCP packets are going to come in, it is going to authenticate the TCP packets or implement the TCP defense mechanism on the packets. If the packets pass the TCP defense mechanism, as we discussed in the last video, then it is going to allow the corresponding UDP packets as well, because the source authentication is not possible with the UDP. So, but we can use the associated TCP packets to implement the source authentication, and once the source has been authenticated using the TCP packet, then the UDP packets will also be allowed, because the source has already been authenticated using the TCP. The second defense mechanism that we can use is the payload check and the fingerprint learning. In payload check and fingerprint learning, what the firewall does is that the UDP packets that are going towards the server, it checks the traffic within the payload or the payload of the packet, and if the payload consists of junk traffic, for example, it's all ones, because the attackers normally just fill in dummy data into the attack packets, and if the packet contains repeated characters, for example, ones or zeros or some combination of them, repeated characters, this means the payload check has confirmed that this is attack traffic, and the firewall will block that traffic. Similarly, if we are doing fingerprint learning, if we enable fingerprint learning, this means that certain specific patterns are going to be repeated within the packet, and the attack traffic is going to have certain specific characters or certain specific repetition of characters. If it detects the attack traffic and sees those characters or sees that combination of characters, it is going to learn that combination, and the firewall will know that if this combination exists in the traffic, this means that it is an attack traffic, and it is going to implement or trigger the fingerprint learning, and using that fingerprint learning, it is going to detect those patterns and protect the servers against those attack packets. Another type of UDP attack that can happen is the UDP fragment attack, in which, if you remember the Fraggle attack, in which the UDP fragments large number of UDP fragments are forwarded, and the host is going to try and reassemble those fragments, and because it cannot reassemble this large number of fragments, its performance is going to suffer, and the server might actually crash as well. In order to protect against these attacks, once again, we can enable the payload check and the fingerprint learning because these UDP fragment attacks are going to contain either invalid data, repeated data, just junk data, or it is going to contain certain specific patterns which are going to be used for attacking the devices. So once again, fingerprint learning and payload check can protect our network against the UDP fragment attacks. The next attacks that we are going to study are the DNS attacks. As you know, the DNS stands for domain name system. In a normal DNS operation, what happens is that a client sends a request to the cache server, DNS cache server, for resolving certain host names into IP addresses. If the cache server has the information for resolving this host name, this cache server is going to respond to the client with the appropriate IP address. However, if the cache server does not contain the entry for this domain name, it is going to forward the request to the authoritative server for this domain name, and this authoritative server is then going to send a response with the IP address to the client, and this cache server is going to update its database with the updated entry for this particular domain name, so that next time when that client any client sends a request for the same domain name, the cache server can respond locally, and this response goes to the client, and the client can start communicating with this server, for example, news.huawei.com. The attackers, what they do is that they attack this particular mechanism or this protocol. There are generally two types of attacks that can happen. The attackers can either attack the cache servers, the DNS cache servers, or they can attack the DNS authoritative servers. They can attack using either the real IP address, or they can be using the forged source IP addresses. Depending upon what address they are using, we can put in or implement appropriate defense mechanism on our firewall. The first attack that we are looking at is an attack which is targeting the cache server. Here an attacker is targeting a DNS cache server, and we can see that it is sending fake requests to the DNS cache server if we want to, and it's coming from a forged source IP address. In order to protect our network against this attack, what we can do is that we can ask it to, if it's sending a UDP, generally UDP requests are sent, we can request this client to send a TCP based request. If it's a fake client, if it's a forged source IP address that is being used, we will not receive, or the firewall will not receive, a TCP based response or a TCP based DNS request, and the firewall will know that this request was coming from a forged IP address. However, if it's a real client, and if the firewall requests the client to send a TCP based request, the client will send a TCP based request, and the firewall can forward that TCP request to the cache server, and the cache server can respond to this request using TCP, because you know that DNS can use both UDP as well as TCP. So it uses both TCP and UDP as its underlying protocols. The firewall can also do in enhanced mode, the firewall can also actually convert this TCP request, this DNS request using TCP, the firewall can convert it into UDP and then forward it to the cache server. So either one of the two mechanisms can be used by the firewall, either converting the request from TCP to UDP or forwarding the same TCP request as it is to the cache server. The second type of attack can be targeting the authoritative server, in which the attacker is trying to target the authoritative server, not the cache server. In this case, if this is the situation, what we can use is that we can use the redirect mechanism, because generally the authoritative servers only use UDP. So in this case, we can use the redirect mechanism. So for example, if a user sends a request for hostname www.huawei.com, the firewall is going to send a request, or is going to send a redirect message and say that please visit abc.huawei.com. Then the attacker, if it's a forged source IP address, nothing is going to come in return. However, if it's a real server or a real cache server, which is sending the request to the authoritative server, it is going to send a new request with abc.huawei.com. It is going to send a request abc.huawei.com. As soon as the firewall sees that the request has come, the redirect request with abc.huawei.com has come, it is going to issue another request, another redirect request, and it is going to say once again to please visit www.huawei.com, which was the original request. Then the cache server is going to again send the request www.huawei.com, and now the DDoS device or the firewall is going to forward that request to the authoritative server, because it has made sure that the request is coming from an actual server and not from a forged source IP address or from an attacker. So these were the two major attacks against the cache server, DNS cache server, or the DNS authoritative server. Even if the firewall has checked the attacks against the cache or the authoritative server, still the firewall is going to keep monitoring the traffic that is coming in, and if a lot of traffic, DNS traffic, is coming in from a particular source address, the firewall can check the traffic against rate limiting, and if the traffic exceeds a certain amount, the firewall can implement rate limiting on the traffic. The firewall can also implement the format, length, and TTL values of the DNS packets and see if the DNS packet format is valid, if the length of the DNS packet is not too large, and if the TTL value is not beyond a certain threshold which we can configure. And if any of these conditions is violated, then the firewall is going to discard the traffic. So these are the different defense mechanisms that we can put in against the DNS attacks, either on the cache server or on the authoritative server. In the next video, we are going to look at different HTTP and HTTPS attacks and how we can defend against those attacks.